Greetings, my little triglets. Today we are going to talk about section 4.7, and it's got a little bit of physics, but very simple physics in it. We're going to talk about simple harmonic motion. And our definition is going to be a back and forth motion which takes the same amount of time for each cycle. So we're not going to include any air resistance or any friction, and we're still going to use that same formula, but instead of x, we're using t for time. So all these trig formulas can be changed to fit the topic that you're talking about. So t is for time. A is still the amplitude. Another word for maximum displacement. And then you do 2 pi over b still for the period. And that means time for one cycle. But we have a new thing, and it's b over 2 pi, and that is the frequency. Frequency is number of cycles per unit of time. So 2 pi over b is time for one cycle, and b over 2 pi is cycle for a certain amount of time. Okay, so next, let's talk about a Ferris wheel. We have a cool looking Ferris wheel here, standing on the ground, and there's a stairway goes up, and then you get into the bucket right there. And from the center to the bucket is 100 feet. This is a big Ferris wheel. So right away we know the radius is 100 feet. Okay, making strange noises. All right. What I'm going to do is, so you can kind of see where it comes from, we're going to draw our little XY chart here where we're used to drawing sines and cosines, and we're going to put it on the grid. And the ground level is down here. So this is up above the ground. So this is kind of like the origin, 0, 0. We'd say right there. Okay, so we have the Ferris wheel is 5 feet off the ground, and it makes one rotation every 30 seconds. And I want you to make a graph and equation for this in 30 seconds. So basically one rotation. Okay, let's start off by making some ideas, some judgments here from the picture. So if I start here at bucket number 1 and I travel to bucket number 2, how far did I go? How long did it take? Well, we said that one rotation was 30 seconds, so all the way around is 30. Half of that would be 15. A quarter of it would be 7.5 seconds. So I'm going to go out. This is the t-axis. This is the, we could call it h for height axis if you want. So t for time, let's put 30 out here. Here's 15. Here's 7.5. This would be 22.5. So right now, At time 7.5, my height is there. At time 0, 0, where you're just sitting in the bucket waiting, is your height is here. But after 7.5 seconds, you've gone this high. So now I'm going to bucket number 3. I keep rotating around and I get to position number 3 here. Well, I've gone another 7.5 seconds and I'm back at this level. I keep going. I go down here. Now I'm at position 4. I am down here at 2.5 or 22.5. And then back at 30 seconds, we're back at the first bucket, so we're at this height. So if I connect these dots, that tells the height. So after a short amount of time, I might only be at this height, so that would be right here. Okay, maybe that's only 2 seconds. So everywhere on here, it tells you, this graph tells you the height after so many seconds. Now, let's do the equation of this graph. You always start out with y equals. You could say f of t equals if you want. So the amplitude, how high is it? Well, how high is it from here to here? And how far down do we go to? What is that total distance? If this is 100 over here, this is 100, that's 100. So it's going to be 200, but amplitude is half. So my amplitude is 100. Then I have to figure out the period. Well, it's 30 seconds. 30 is our b. So it's 2 pi over 30, which is pi over 15. 30 is the period. 2 pi over b helps you get the number in the equation. So I have 100. Oops, I gotta put my sine word in there. Get rid of that. Okay, because it's a sine wave. And then pi over 15 is the b because the period is 30 and you do 2 pi over b. Yeah, I should really do it this way. 2 pi over b equals 30, and then you can switch those two. That's how I got this. And then we have to decide if it's moved up or down or left or right. Because it starts on the origin, I'd say it's not moving right or left, so we just put t for time. And remember, this was 0, 0 down here. So how far up have I moved the entire graph? Well, the radius is 100, but remember, the wheel is 5 feet off the ground. So we've really gone 100 plus that extra 5 feet. So we have to say plus 105. So that would be the equation of this graph. Okay, so the only real new thing is the frequency. It's basically just the reciprocal of the period because they are inverses of each other. Okay, I think that's it for today. So I know today was a bit of a carnival for the notes. It was very fun. Ta-ta for now. Don't forget, Trig is joy. Trig is happiness. Trig is love. Trig love. Bye-bye.